Yes.
Okay, Mike's live. Cool. So we on the hour, tight agenda. So let's start. Welcome, the usual nada nada, IETF 116 beer, world domination, and all the other smaller things. So today, Greg is looking at fishes, literally. He went scuba diving. So Sandy is co-chairing with me. And with that, what do we need first? The node well or status? Who's you controlling the preso?
Yeah.
Okay, well, nothing gone. So share the screen, please. Yeah. Mm-hmm. All right. Okay, so the usual node well. You do not expect me to read that stuff. Okay. Meeting tips. Right. So please do the on-site version thing because it somehow magically counts. Otherwise, next time we get a broom closet for 3 people. Okay. And yeah, we're all the mask thingy. Otherwise, we all die a terrible death. In some unspecified point in time. All right. I don't know what, do we have remotes? Probably 18. Yeah. Okay, cool. Next one, please. Resources. You see, first time co-chairing, she takes her job really seriously, all the small print is all here. Good. Minutes, yes. So I don't know what the Jabber situation is, but we need someone taking minutes. Mana, you're not supposed to be smiling if you want to avoid the job. And we have Ice back, who will be a great minutes taker. So Mana, you're just too nice, man. You're always smiling. You get caught into these things. We used to have stickers for the note takers. Where is the stuff? How am I supposed to motivate the crowd? Thank you. All right. So please, minutes. Next one. All right. So Sandy will be doing the agenda and the status, and at the end, I will have some mild, griping to do about the status of the charter and where we are with certain things.
Okay, thank you. I'm Sandy Zhang from ZTE. This is our agenda today. Please review it, and if you have any comments.
Closer to the microphone.
Oh, sorry.
And
Sorry.
Say that we changed the sequence. The time was at the end.
Okay. Sandy Zhang from ZTE. This is our agenda today. We changed some sequence and move Huaymo's presentation to the last end. Thank you, Huaymo. Yeah. And let's see the working group document status. We have 2 drafts in IESG process. One is OSPF v3 and the other one is BIER-EVPN.
If I can just ask, Tony, I know we spoke about the OSPF v3 drafts, and we were waiting for a couple of updates in the write-up on that. Is there any progress on that?
The OSPF v3, yeah, I chased the guys, and I think all the stuff has been closed. Has that been pushed forward to ISG?
Okay, I will check because I didn't see any notification or any emails on the Shepherd write-ups, etc., and I was waiting to hear on that.
Okay, let me double check on.
Yeah, I'll also double check. It's just that nobody. Yeah, if it did.
This
change.
minute, sir.
Okay. Cool. Thanks.
So we have 4 drafts that completed the working group last call, and the Shepherd's review has done. And please comment and questions if you have any before they are sent to IESG. And we have some drafts ready for last call. One is beer MLD, and we need Shepherd's review. So, and we have prefix redistribute and OM drafts. They are present in this meeting. And we still need some volunteers to shepherd these working group documents for early review. Please volunteer for it. Thank you. And according to the charter, we still need to work on OEM, just mentioned it, and the young model. There needs to be refreshed and pushed to working group last call. And the applicability in EVPN has to be written per charter. And the PCE on programming BFRS is open to be written. BFR use cases need to be revived. And we have PCE 40 already, but needs no more one. Okay.
Right. So we have still, a good amount of stuff on the charter that either lapsed, so it needs to be picked up because we are obliged to deliver that, or otherwise, we have some holes that needs like applicability in EVPN that need to be written. Lots of room for improvement, so to speak. Okay.
Thank you. And thank you. That's all. Yeah. Any comments?
Okay, so back to the charter, back to the agenda, first presentation, Greg. And please keep on timer. We have to get through.
Okay, next slide, please. Okay, so as just an overview of the status of the OEM work in BIER. We have 4 working group documents, ping, MTU discovery, applicability of BFD in BIER, and performance measurement using on-path telemetry alternate marking method. Next slide. Okay, so just to recapture, the BIER ping is one of the basic, the ping is one of the basic known mechanisms broadly used in different network layers. For BIER ping, we define their message, and yes, you will find a lot of commonalities with the LSP ping, but there are some lessons that we learned from MPLS LSP work, and we use that here in a ping. This document already been for the working group last call. We received comments. Yes, we were a little bit slow on addressing these comments. The latest version with offers believe that does address all the comments received in the write-up, and we appreciate our shepherd to look at this and give us a feedback whether all comments addressed, if the document can be taken further in the progress, so that because other OEM documents, they have a dependency on the progress of this document because they propose several extensions.
Greg, quick question. The changes, they justify another last call, short last call? Or
no, there were editorial changes.
Okay, thank you.
Thank you. Next slide, please. Path MTU discovery. So again, as I mentioned, it does need BIER ping because it enhances the registry, adds a new TLV. So, and proposes the mechanism that takes the advantage of PMT, of BIER architecture solution, so to make path MTU discovery more efficiently. And we are ready for the next step. I believe that I'll check the status. If I'm not mistaken, it says that consensus waiting for the write-up. So I don't think that it has a shepherd, so probably looking for
okay,
shepherd.
need shepherd. Okay, good, thanks.
Next slide, please. Yes.
just also, have you guys requested the early reviews for those things? Keep in mind that we are asking for RTG for the directorate early reviews. So if you push those to the reviews and you want to move them faster, the faster those requests go in, the faster the documents will be processed.
I think it's an excellent idea. So
The RTG reviews were kind of optional, so now that you're required to push them on the early RTG reviews?
Yeah, there were mails about this to all our working group chairs.
Yes, I stand castigated. Okay, fine.
So yeah, the early directorate reviews. So you need to get those requested in.
Thanks.
yeah, of course. So and offers, I can speak on behalf of offers. We are ready to work with the comments from our early RTG directorate review and address them in reasonable timeline. BIER BFD. So since BIER is a multicast environment, it relies on two BFD specifications for multi-point networks. One is 8562. It's a base specification, but it only allows for the tails to know their state of their multicast distribution tree and a head and a root, and it does not assumes or defines any of the mechanisms to keep the head root / root aware of leaf well-being on the how they perceive the multicast tree well-being. 8563 enhances this functionality, and it allows for active tails and defines several methods that can be used by by the head of their what can be characterized as a point-to-multipoint BFD session to gain understanding of the state of the multicast distribution tree and the leaves. That includes whether multicast polling, or it could be a hybrid polling, so basically combination of multicasted polling sessions combined with the unicast polling sessions that are diverged from the multicast distribution tree. So basically, it is beneficial, of course, logical, to have unicast polls. You can consider them to be as mechanisms similar to echo request or echo reply to be sent and disjoint path from the multicast tree. So that thus, if there is a failure in a distribution tree, then their unicasted poll message with the final more likely to gain valuable information. And also the method that is defined more closely is unsolicited notifications. So that actually that notifications, that method can allow for faster notification to the head of the failure in the multicast, because the initiative is on the leaf, and once the leaf detects the failure of the multicast distribution tree based on detect interval and frequency of their BFD control messages being sent by the header, it sends a notification to the head end rather than rely on a polling interval by the head. So we think that this work is ready for the working group last call.
Okay, we'll call that then.
And next slide, please. Okay, so hybrid performance measurement in BIER. In IETF, we working on and developing two methods of hybrid performance measurement, or it's on-path telemetry. one of them in situ OEM and alternate marking. So this method, this document proposes use of alternate marking method.
Greg, quick question. That is heavily IPR. The IPR has been disclosed?
On this one?
Yep.
Um,
From your side, is the IPR all clear?
I need to check.
Please check the IPR.
Yeah.
Yeah. No, thanks.
I'll check that. Alternate marking method in situ OEM is being discussed applicability to MPLS network within discussion of MPLS network actions. So that probably would be a better solution to do it on MPLS. In the meantime, as you might recall, we received comments from Alvaro. The latest version, we believe, that addresses these comments because the suggestion was to make this application of BIER header as one of the use cases. So they make the use of alternate marking method, particularly the OEM field, as one of the use cases. As this document was in the processing, we had good progress on alternate marking specification. So you might recall that originally these documents were published as experimental. So now they've been reworked, and both documents for point-to-point to point-to-multipoint use cases are published on a standard track.
Okay. Out of time, couple questions. So what's the next step? You think this stuff is ready for last call, or you
Yes.
do it? Okay,
Yes.
last call. Shepard assigned or not?
I think so, yes.
Okay, otherwise I'll check. Last question. The requirements and the framework documents, they kind of lapsed. They have the value. Should we pull them up and last call them, or should we just let them fade?
It's probably for the group to decide. I do think, again, they served their purpose as a guidance for what we're doing and how. It might have a value as being preserved. For now, yes, the requirements expired.
Any opinions in the room? I think the framework is kind of a good way to think about, the stuff without getting into tons of details. Requirements, I agree, we can let it lapse. What you take, Andrew?
My kind of opinion is that if you've got a requirements document that served as the basis for the work that you did, it's always good to revive that, get it published, and have it there as a backward reference.
As a tracker.
People can have a track record about why you did this. So that would be my personal view on this.
Okay. You willing to do that, Greg? Otherwise, we'll
I'll do the work as working group decides.
Yeah, so just revive the stuff, and we pretty much last call the stuff that doesn't need, excessive amount of review. And I think they were of very high quality. So I'm also kind of, my heart bleeds, right? A lot of effort went into the stuff with a lot of people.
Thank you.
Yes.
Okay, thank you for your time.
Thank you, Greg. Okay. Call is in the queue, so snappy because
Yeah, so if this requirement stuff is only informational, it doesn't even need to mean that it has to be finished as an RFC. Not that I would like to see that, but there are successful technologies with just still draft informational references to requirement documents, right? So that wouldn't be the first time. My question was, how about any implementation experience or public stuff about these OEM things?
Good question. I accidentally got feedback from one of the vendors that they implemented LSP ping as a current specification. So that's a good sign. I think that probably if we move forward with other documents, it will encourage vendors to follow through, because understandably, there is always a risk, and frankly, due part my fault, they were not progressing as they should have been.
Yeah, everyone's busy. I mean, we at this point in time and technology is being deployed. There's a bunch of silicon out there. We have to draw lines in the sand and give people, standards RFC they can basically do, all this RFP work on, right? Okay.
Thank you.
Thanks. All right, so I will be in control. Good.
And okay, I'm Sandy Zhang from ZTE. This presentation is for beer prefix redistribute. I presented this draft on behalf of our co-authors, Jeffrey Ice, Yisong, Human, and Bo. Next, please.
Page down? No, it doesn't work. Okay.
Okay, let's take a brief review on this draft. We know that in some networks, a single beer subdomain may cover multiple underlay routing protocol regions, such as AES or IGP domains. And when we use BGP-LU, and the beer prefixes can be redistributed among the AG routers. But if we want to build a unique beer forwarding plane across all the regions, how can we do it? So the motivation of this draft is to advertise the beer information into these regions to build a beer forwarding plane. And a new beer proxy range sub-TLV is defined to improve the advertisement efficiency. Next. So this draft has been presented in last meeting, and after that, we made some changes for it. We removed the subdomain ID in the proxy range sub-TLV because there is a subdomain ID field already in beer sub-TLV. So it's not necessary to carry a repeated subdomain ID in the proxy range sub-TLV. And we improved the examples in the draft according to RFC 6890. Next. So more comments and review are welcomed, and we'd like to request for working group last call again. Thank you.
Okay. How many read the draft? Hands up. Okay. So there was some attention paid. Ready for work? Last call, the whole thing? Mana? Yeah, okay. Cool. So I give it attention and then let's see whether we push to the last call. Yeah, thanks. Okay, there's someone in the queue.
Hi.
Name, affiliation, please.
Hi, it's Sue from Hawaii. We have a question about the prefix address because in this draft, the several BFRs in one single IGP domain is concatenated into the sub-TLV. So we want to know whether the prefix of the packet will be a host address or a prefix address that contains several BFRs addresses.
You can use the method to advertise the prefix one by one, and you can use the host on the host address of the ABR to advertise it. Yeah.
Okay.
It's both work. Yeah.
Okay.
So
because
I encourage you at the section clarifying that because the question is good. Yes.
Okay. I'll do it.
So the question is that because in RFC it mentions that the prefix have to be a specific address. So maybe we think the ASBR address will be the correct answer to this question.
Quite answered. So
no, I mean a better solution to this problem, because in IFC it mentions that the prefix address have to be specific. The length have to be 32 or 128.
Yes. Well, but does BGP summarization, violate that?
Yes, I think if you use a segment address, it will violate that. I mean,
That, okay.
So do you mean that we advertise prefix with multiple BFR IDs?
yes,
Yes, we do that because we, if we would like to solve this problem, we must do it.
okay. So we will talk about this problem later, maybe.
Okay.
Yeah, and you know, the problem that may of course occur is that when you advertise the prefix, but it don't cover all the host addresses, the usual stuff, right? So you end up on blackhauling. But it's good. Yeah, good clarification section. Thanks.
Okay, thank you.
Okay, so that needs clarification. Okay. So I encourage you to take it to the mailing list nevertheless, because that is the only thing that really survives, right? As something that we can, you know, that preserves history, so we can actually go backwards and see what happened when people discuss the stuff. So mailing list is always better. Otherwise, no discussions are fine, and then to document, but mailing list would be also good. Okay, thanks. Keep the time. I do that.
Okay.
I do the timer. That's okay.
Okay, so this presentation actually covers two drafts related to Anycast. The co-authors include myself, Ice, Sandy, Manka, and Huaimo. Next slide, please. So Anycast is a viable practice used for multi-homing protection on the service egress side. There is RFC about it, and at least it's a viable solution for unicast. Now, for BIER, it did not consider Anycast initially. These two drafts cover the BIER with Anycast. In this slide, I have a picture showing that we have P0 through P3, where CE1 is multi-home to P1 and P2, and the P1 and P2 share an Anycast address 1. And then CE2 is multi-home to P2 and P3, who also share Anycast address 2. And then CE3 is just single homes. We want to make this to work with BIER as well. Next slide, please. It turns out that BIER can easily support Anycast. So a non-zero BFR ID can be advertised from different BFERs as long as they have the same Anycast BIER prefix. And the rest will just work out automatically. It's like eSIMP to a single BFER. Of course, different BIER or BFR prefixes must have different BFR IDs if the ID is not zero. Notice that a BFER may have multiple BFR prefixes, whether it's Anycast or not, in this situation that we want to address. Each BFR prefix will have its own BFR ID. Allowing these multiple BIER prefixes is so that we can have different multi-homing protection groups. In the picture, in the previous slide, PE2 can have two Anycast addresses associated with it, and as a BIER prefix. So if a BFR IR, ingress BFR BIER router, it has Anycast BIER prefixes, then when it sends traffic, it needs to use the appropriate BFR ID when it has multiple of those BFR IDs. Of course, we would want to minimize the number of BFR prefixes, because that way we can reduce the number of bits that are needed. As long as two BFERs can protect all the same set CEs without daggering, then a single BFR or prefix should be fine. But in the picture, in the scenario in the previous picture, we will need two. Next slide, please. So a legacy BFR that might treat the same BFR IDs advertised from different BFERs. They may treat that as a duplicate. So when that happens, the BFR ID will be treated as invalid, and relevant BFERs won't get received traffic. When that happens, an error log message will be logged per the requirement. So to make use of Anycast-based egress protection, all the BFRs in the domain must support this feature. The error log message from legacy BFR will help identify the situation. Normally, when the operator deploys this feature, they will make sure that they should make sure that all the routers can support the feature. But if somehow they missed it, and there is a legacy router in the network, then the log message will help identify the situation. We thought about signaling a BFR's capability of supporting the Anycast. The conclusion was that it does not really help, and it is not needed anyway. And the error log messages will help identify the situation. So we just decided to go with the simple solution. That's just make sure that all the BFRs support this feature. And if you somehow missed it, and then the error log message will help you identify the situation, and then like just upgrade the software should be fine.
So I'm a little bit confused about which of these pieces relate to the use of an Anycast BFR ID in the BFR ID field of the beer header, meaning for the source side, versus in the combination of the SI and the bit for the receiver side, right? So I think either of them can be Anycast, and it's unclear which of the things you're talking about relate to an Anycast source or an Anycast receiver bit.
This slide is talking about on the receiver side, and in the previous slide I mentioned the ones that if you are a BFIR and you have multiple beer prefix associated with you, when you need to make sure that when you send traffic, you want to use the appropriate BFR ID in the packet.
So, and then in the case of having the same bit, so to speak, assigned to multiple receivers, you would also like the normal Anycast that whatever is the shorter path from a particular route on the distribution tree is the only one that should get the traffic.
Right.
Okay.
Yeah.
Yeah, I think it would be good to clear that up. I haven't read the draft. Maybe it's clearer than the slides, but thank you.
Okay, thanks. Next slide. So there are some considerations for the flow overlay. Here I'm using MVP as example. So the CEs connecting to the PE or BFERs, they must signal multicast interest to all multi-homing PEs that are in the same Anycast protection group. In case of PIM or MLDP, the MOFR feature will work. The CE will send joins or label mapping to both. And typically with MOFR, the downstream router will only accept traffic from one of the upstream neighbors. In this case, the PE needs to be prepared to receive traffic from any of them, because the two Anycast BFERs, only one of them was receive traffic, and then whoever received traffic will forward the traffic downstream. So the CE needs to be prepared to receive from any of them. Another example of that signaling between the PEC is the IGMP MLD proxy with multiple upstream interfaces. That was discussed, I believe it was in the PIM working group. So when this Anycast BFER or PEs receive that join from downstream, they will all signal MAPM C multicast routes and leaf AD routes using corresponding BFR IDs. Want to point out this procedure works for MAPN. It does not work for EVAPN because EVAPN does not use Anycast for multi-homing procedures. I had intended to write a paragraph or two to explain why it does not work for EVAPN. That may or may not be added to the draft. Next slide, please. So MAPM tunnel segmentation, it can be used here. If you look at the picture on the right side, we have three subdomains, 1, 2, 3, and have PEs in each subdomain and segmentation points between the subdomains. With MAPN, the tunnel from PEs to PEs, when they go through different regions, they can have different types, or even when they have the same type, they can have different instances in different regions. Here, each subdomain is a different region. So in this case, the reason this segmentation is used here, even when all of them are beer, is so that you can have many support many PEs or many BFERs here without having to send multiple copies. Here, the PE1 can send one copy to reach PE2, PE3, and the segmentation points, and it does not care about other PEs or other segmentation points in the downstream regions, because segment points 1 and 2 will be responsible to send traffic down. Here, those segmentation points, they can be Anycast BFERs. They are the BFERs in the upstream subdomain, and they are the BFIRs in the downstream subdomain. So when the segmentation points re-advertise the MAPM PINZ routes to downstream, they need to use the Anycast beer prefix and BFR ID in the advertisement. Now, if you look at P4 and P5 and segmentation points 3 and 4 in this subdomain 2, they are the BFERs in the subdomain 2, and they will send leaf AD routes to the upstream PE or to the upstream segmentation points here, which are the seg1 and seg2 here. When they do that, they will use their the seg1 and seg2's Anycast. No, they will use their own Anycast BFR prefix and BFR prefix if they are the Anycast ones. They are also like the CEs to the Anycast PEs that, as we described earlier, when we are talking about upstream subdomain. So in this case, the leaf AD routes from P4, P5, Seg3, and Seg4 are like similar to the PIM joins that Seg1 and Seg2 may receive from downstream router. That's just an analogy.
Okay, Jeffrey, we're short on time. That will need discussion. How much stuff you still have?
Oh, almost done. This does work with EVAPN. Next slide, please. Skip this one. So we have two drafts here. The first draft is very simple. It's just an extension to the base spec to explicitly allow Anycast and explicitly tighten the duplication detection rule it should be standard track. The next one, the overlay drafts, is on the borderline of standards and informational. Mainly that's with basically clarify the use of Anycast BFR prefix IDs in the MA pin, pin 0 leaf AD routes. So
Okay,
that's
Toles.
it.
Can you go back to the first slide with the picture? Sorry. Yeah, that one.
Yeah.
So the whole Anycast for the BFER, that's a cool idea, but we didn't have the equivalent to that, right? So how would this work in this case if basically CE1 right now joins to PE1, but then P1, P2 have an Anycast group, and in the core you get a failure, and the traffic now goes to PE2, and there is no join from CE1 coming to that, right? So would the receiver Anycast work here? So sender Anycast, fine, but receiver Anycast.
That's why I was saying that the CE1 needs to use the PIM or MLDP MOFR feature where it sends multiple joins to the different upstreams.
And then whether or not we're actually sending from both sides may, yeah.
I'm also on the queue, right? So my observation is that so the architecture in this sense is sloppy because we don't have really formal UML model with all the multiplicity and associations, right? Like how many, prefixes, prefixes on a node we have, but like how many BFR ID per prefix and so on, we don't have that. That can be a feature or, a bug. You try to play it as a feature. I think that needs very careful reading and reviewing and rethinking. And from my side, the observation would be you have to advertise the capability somehow, because if I build a multi-vendor network and I'm plugging a node in and I have problems, to go log scrapping of all, 16,000 PEs is not an option, right? So we need something where we can build an automation or a tooling where I can actually discover compatibility or not of how this is interpreted. And I think it is in current architecture and specs, it is perfectly fine implementation that you actually send a copy to both guys, depending how you build the BIFs. Okay? So that will be observation from my side, that if we start on early semantics, this better be done very carefully and in a way that can be actually figured out in deployment easily. What kind of interpretation you're putting on a replication of BFR IDs, whether it's a bug or you send to both or you really do Anycast from my side. Okay, thanks.
Hi, Sue. And we have a question is that, so as shown in the picture, the PE2 is multi-homed by CE1 and CE2 simultaneously. So in the draft, you said we will have two different BFR prefixes and two different BFR ID configured on PE2. But we think in IFC 2879, the architecture IFC, it mentions that the overlay and underlay should be decoupled. But in this scenario, the overlay and underlay here is coupled because the underlay configuration needs to be configured depends on the overlay situation. So,
I'm not following the overlay versus underlay argument, but regarding the architecture point that in RFC 8279, indeed, here we are giving the two BFR prefix and IDs to the same PE2, but you can think of it, another way to think of it is that PE2 here is actually can be like two separate logical routers. Another way to think of it is like that. But if we want to say that, okay, this is absolutely strictly fine with our architecture RFC, then we can look into if this is a safe thing to do to extend that architecture to explicitly allow this. We can go through that exercise. That's fine.
okay.
Yep.
All right. I think we ran out of time. That I would say will merit a good amount of thinking and discussion about when we really go and fiddle with the semantics. I mean, nice skidding around the grayish area of the architecture how it was specified, but if we do that, it better be good nailed well. Okay, Torres-on.
All right, quick update here on what we've been doing with respect to the recursive bit string work. As you see, a couple more folks starting to engage on it. Next slide. Yeah, so no draft update. So it was really all the other work around it that we've been doing. So thanks a lot for ICE providing feedback on issues last IETF, and the one issue that was open in terms of how to deal with a mismatch between the bit string length on the sender and then the processing nodes. When I got down to that thing exceeding 2 pages of text, I figured that I really need to start writing that into a draft, which I didn't manage this time. But a lot of that, I think, is also applicable to BIER-TE. So I think that might actually become a useful informational document then. And so the answer is, yeah, we know how to do in the forwarding plane, add the bit string length as a field. That costs a lot, so we'd like to avoid it. And control plane to the rescue to keep the forwarding plane compact and efficient. So definitely by next IETF. Next slide. Oh, do you want to immediately question and comment? Yep.
Yeah, maybe if you don't
Of
mind, ICE Arcus.
Yep.
We'll just jump in since you
Of course.
brought up the topic. So there are basically 2 issues, right, that I mentioned in that email thread on the list.
I thought I answered the other one, so yeah, okay.
Yeah, well, it didn't solve it didn't answer it sufficiently to me.
Okay.
It didn't solve the problem. So in the length that you mentioned, right, that should be fixed. Also, whether the encoding is recursive or not. This is also you cannot hear me?
No, it's fine. It's
okay. Because new noise.
Yeah, no, that helps.
Also, whether the recursion, the encoding is recursive or not, is also part of the state in the router itself, right? That should also be encoded inside the packet. And basically, as a sort of how, if you want to sort of prove your encoding, if you put a sniffer on the wire, it should be able to encode the packet, right? It should not be depending on operational state in the router. So I think that's really important. I think you should fix that, sooner than later.
But I think that there's the answer that, no, I do think that the operational state in the router in the same way as, for example, in an MPLS router, unicast, where you also need to have the right semantics known for the label SID, call them what you like, right? So to be able to analyze what's happening there.
Yeah, no, so I don't think that's a good analogy because even with MPLS, a sniffer on the wire can always decode the packet. Let's say what the label means, right? That context, okay, that is on the router, right? But I think in IETF, pretty much all of the encodings that we define, right, a sniffer can decode it. At this point, your encoding, the sniffer is just unable to decode it.
I didn't get that. And right now I would say I do not want to agree because I think I can be more efficient on the wire if I don't do this, right? So, but at least I now understand the point, right? And we can continue to have the argument.
But doesn't it boil down only to the argument whether the first thing that you decode needs a length indication, right? Because the rest after that has lengths, right? So you know how big they are.
Yeah, so...
No, it happens recursively on every hop, of course. If you don't know for every...
Yeah, but on a single hop, it's just the first field that you need the length, because after that, there is an indication of the recursive part,
so,
right?
And I don't think you should be able to decode the whole bloody tree that's encoded 5 or 6 hops down in the same way that you're not supposed to be able to decode, a stack of protocol encapsulations that you don't care about processing. So that's the argument for not being fully explicit in the packet, but only explicit to the degree that you need to process it in the forwarding plane.
Yeah, no, well, I very much disagree, but Tony, has to answer your question. So it needs a length field, so you know what the BIF site is, and I think you need to do it for all of them. But also whether there's a recursive encoding, that information is also not in the packet, that is in the router. So if the router receives a packet, it has a recursive bit set, and then you know that you need to look further down. No, that's also not in the packet.
If we would have the length field, right? So which is perfectly fine. It's just I think it's too much overhead. Then you could decode the whole tree because on every recursion step you have the same.
Correct. Yes.
Yeah. Now, but just because you think it's too much overhead doesn't mean you need to discard it, right? You need to build a protocol which is reliable and can be troubleshooted by somebody.
Of course, yeah.
Right?
That's the alternative.
So that's
what I wanted to write down. And if that fails, then we're going back to the length fields. Exactly.
Andrew here speaking as me. Just without going into too much detail, for me it is critical that you can decode a packet outside of just the forwarding plane, because we use that functionality for a whole bunch of things. Everything from, you know, when we're doing packet accounting with MPLS, packets are going to be able to jump past the stack, potential DPI applications, etc., etc., etc. And so that is a very, very important thing for pretty much any operator that we are able to do that.
No, completely agreed. I would just say that not all of that has to be solely in the forwarding plane. So, for example, anybody that starts to work with anything encrypted also needs to be share of the keys to be able to continue to decrypt. So that's part of a control plane. In the same way, if you want to have semantic decoding of anything that MPLS does, you need to have knowledge from the control plane. So if you want to spoof, if you want to do the diagnostics, it needs to be control plane and forwarding plane that you have access to.
Not entirely. If I look at, for example, on the encrypted stuff, okay, they're about to change the SNI and encrypt it, but I don't, you know, I can get to a certain level.
Yes, of course.
When it comes to MPLS, if I'm doing packet accounting, I know where the bottom of my stack is, and I know where to read the next header out of it, and from there I can go.
And that is the same.
Yeah, I don't need to know the full semantics, but I can still, you know,
That's already given, right? So to be able to skip over the bloody, you know, RBS header if you don't care, that's already a given. So we're discussing about looking deeper into the RBS header itself.
There are, I mean, other tricks we can play. Since this will be a completely new interpretation of the beer mask, we're on a subdomain that, you know, can do crazy stuff. We can, for example, after the beer header, add the length information that you capture if you need to decode the stuff, and normally you don't process in the forwarding plane because you already have it. I think there's a good room to play around with ideas. Okay, hey, come on. Let's continue.
Yeah. So sorry. I mean, how about 5 p.m. and beers to have really beer discussions, because this was just meant as a status update. So there's the great discussion that Tony and I had about the core option in terms of using either the SRv6 model of having pointers, updating the pointers into the header, or stripping, which is more like MPLS, and then you can have potentially much larger header. And I was flipping in one direction in version 02, which we have right now, and I think I'm trying to find a way to outline, maybe not in this draft, but in informational, you know, to die draft, the impacts of the different options so that we capture them and can actually discuss them. Oh no, not more. Okay, please.
You
Association name, Ren, please.
Ask now or after your
Yeah, please.
Yeah. Xuesong from Huawei. Actually, although I'm also the co-author of the document, it's interesting argument about you and ICE about whether we should keep the length or whether the variable length helps to the encapsulation expense. I think there is another point that we should pay attention to is whether we still need to get rid of the in-related tree when we completing one replication.
I'm really running out of time, and I think thanks for the feedback. Let's go to the next slide.
Yeah.
Nope. There we go. Right. So we've been starting to work with the University of Tübingen, you know, who've already been given update on their P4 implementation of beer and optimization of that twice here, and they've got a lot of other beer related work. So one of the things that we already saw as being prerequisite to analyze RBS and so on was kind of a comparison of efficiency in terms of number of packets with different type of trees, different size of networks. So we got backlogged in the RBS work by that just being a huge 16-page research paper that is going to be published soon, and then hopefully we'll also be able to get in San Francisco an update on that, not even necessarily in beer, but it's comparing beer and multicast, so we'll see where it goes. And then of course looking into you know, a reference open source implementation of RBS, or how much of RBS we can get in P4, and not that we as vendors may be interested, but I really like to have you know, an open source reference implementation so researchers can start deploying and playing around with this building application the same way they can do it with a P4 implementation with with beer now with that implementation, and we already saw that, for example, the Beijing University was porting the beer work to IPv6 so they could experiment with MSR. So I think for research, this is quite important. And then next slide, final slide.
So as to the APIs, we should probably hook up with DevNet, Jamal and those guys, right?
Yeah.
That should be a good huddle down. I put
that's yet another thing, and even explaining what are the applications in a data center you can do, right? You told me what are kind of the pull applications are where service providers really want to deploy, but obviously I think there are a lot of push applications where you need to tell the people you could use beer and beer TE and this stuff to do better than multicast, and somehow we need to start making progress on that. So yeah, this was kind of a working slide for all the different alternatives that we've been looking into. So that's what University in Tübingen did on analysis, starting with BRTE, which is simple. So, but of course, everything in P4 on Tofino is more work than just BMW V2. Then the difference with a local global segment. So this is similar to these MSR6 proposals where we have actual SID and a tree of SIDs, which is nice for overlay networks because you can go across arbitrary hops and don't have to bother about them. But for native deployments, it's probably not scaling. That's basically the beer with mixed segments, and then RBS. And since then, we've been looking into how can we do modifications that make poor Tofino happy, which is a little bit a problematic forwarding engine in that respect. So yeah, so that's just to show you that there are a lot of alternatives being investigated, but it's likely going to end up with just a lighter version of RBS that may not be as efficient and as good as on the real router.
So we have a minute. So from my side, so I read the drafts carefully, looked at the progress. More not only from the angle will it work, right? So that was, I had a couple of bubbles coming up, like you can split it into 2 trees, that's how we scale and so on. But also from the angle, if we stick it into bit mask, we'll violate any of the security architecture, OAM, right? All the stuff that we have around to actually make it, something that is operationally deployable. And from my side, looks good. It could solve, the use case that we'll be talking about later, right? Or let's put it that it's the best candidate to solve this kind of use case in beer. Kind of very similar to the BRTE, right? This just another interpretation of a bit mask, and you have a subdomain where you just, use it differently. We don't have the charter for it, okay? So the request will be, is the working group willing to work on the stuff? Can we, twist the AD's arm to actually push the charter to work on that stuff? From my side, like I said, this fits nicely in the architecture if that's what people want to work on, and, let's see what that addresses.
Isaac, just want to make one comment here, especially about the RBS. I would like to see the fundament of that technology and the encoding to be really solid before you engage in doing any kind of P4 simulations and testing, because if you have to change your encoding, then all the testing you did might be useless, right? So just want to...
Right. But the fundamentals in coding are kind of 2 different things. Yes, they play at the scalability. There was the scalability comment that I made, right? How big can you make this tree? And I have a lot of concerns lightened there. Okay, because if you run out of space to encode the tree, you just send a part of a tree, and then you encode the second tree on the second part of the tree on the second packet. So, and when you see the use case, when you do that, it will be still far better in the deterioration you can end up, with standard beer, flat beer.
So my comment is not for the original idea of RBS. I can see how that benefits, and there are use cases for that. But just trying to make it very efficient encoding, but you come to the conclusion that it doesn't work.
But if we don't work on it here, then what? We wait for them to work
first make sure it's solid that you can decode it properly, and it's going to be longer, the encoding, I think. So it's going to be less efficient. But if you don't make it solid first, you might have just wrong data that you're looking at. That's my point.
But let's say this, right? So we have a real network processing unit hardware implementation, right? And hopefully we can also show that at a hackathon and use that there. But the P4 work is so that the research community can also do something, because usually they can't, play around and do things with a real routers. That doesn't have to become the standard, right? So this is just an effort in the overall solution game, right? And the actual encoding that we want to agree on is just, you know, what the vendors, whoever plays in the IETF has a voice. If somebody wants to stand up for P4, we're not going to stand up for what P4 makes work, right? That's just the research part of it, right?
Do you want this to be just a research?
No,
thing,
that's what I'm saying.
This to be an actual deployment by you know.
No, but what I'm saying is just saying yes, of course, and we can show you we have a hardware implementation on the routers, right? That may be the only thing. And then other vendors are claiming in and saying, yes, we think we can also do it. We've validated. That's, again, for the standardization, the only thing of interest, right? That's how we did it with beer, right?
No, we didn't. But what? I'll take it offline.
Okay, sure.
Okay.
Just Andrew, with my AD hat on, to answer your question, if the working group feels that the stuff is what they would like to work on and there is consensus in the working group, I do believe that this would fit within the overall framework and it should be a relatively easy thing to add to the charter. I just need to be sure that this is something that there is sufficient interest within the working group to work on and that the working group would like to do that. And so what I would suggest is if we could either take it to the mailing list or get a hum in here or something, just so that I know.
Should we just have a poll?
That would also work.
Can we start a poll? Because this is worth doing now. I need this info.
Oh, where's the poll button here on this thing?
Oh, there was something here. Note taking. They had this stuff, but they always show of hands tool. So what is the question? Who would not like working on it, right?
Who understands what we're talking about?
let's not make the bar too high. Okay.
So Tony, can you clarify what does raise hand means? It's very confusing.
Okay, who would contribute to work on RBS and beer working group? That should be pretty clear.
Yes. So if you want to contribute, stick your hand up.
Okay, 13. Raising hand or not?
Sure.
Okay. All right, I have 6 not raising, 7 raising, so more than half is for it. Should I do another poll? Who is against adopting this stuff, or that's good enough?
I think let's ask the question of the people who don't want to work on it, who is against it? So that, you know, because there's a big difference between I don't want to work on it.
Yeah, correct, yes.
And I object to this at all.
So what? Raise of hands? Who is objecting to adopting that as a work group, you know, into the charter? Or it was just passive? Okay, so 2. Okay, so we have what? 2 objections, 2 objections for the staff. We have 4 objections. What is that? Okay, so we have 5 objections to adopted staff. We have 7 people who want to work on the whole thing. All right. So you call the shots.
Let's discuss this offline.
Okay, so we'll need more discussion. I would say we take it to the mailing list and ask the question, like, you know, do you want this working group to work on the stuff on RBS? Otherwise, fine. Okay.
Yep.
Good enough. Mhm.
Thanks.
Can I give 1 minute for the explanation why we want to object to the adoption?
What? Do we open the discussion to the mic, Andrew, or we put the stuff to the mailing list?
I would. I personally think that it could end up in quite a discussion, no matter even if it is one person, and therefore it's probably best in the interest of time, because there is other stuff on the agenda, to take it to the list.
Okay. Okay, so I have 8 who want to work on it. Raise hands. Okay, cool. So, fine, we'll take it to the list. That's my screen still? No. Whose screen is that? All right. Do I have to clean up the stuff now? let me see. All right, dismiss. So next presentation. Are you sharing screen or not? Now it's stuck in this voting mode. Oh man. So what do we do now? End session. Okay. All right. So we have it from here. Okay. 8 rays out of 15. Okay.
Hello everyone, I'm Zan from IETF. Today I would like to do the presentation about PCEP extensions for BIER-TE on behalf of all the co-authors. Next, please. This is the introduction. This document specifies extensions to the PCEP that allow a stateful PCE to compute and initiate the path for the BIER-TE. Next, please. This page includes the extensions of PCEP BIER. We have do the practice many times in PCE working group, so skip it due to the time. Next, please. This page is the update. We update the draft based on the comments from the IETF meeting. We add the reference to FC 8623 and also add the use case of objective function and add the LSP object to identify the BIER-TE path. Next, please. This page is the relationship with other PCE BIER drafts. There are 4 drafts related to the PCEP BIER or BIER-TE. The first one is the one that we have done the practice. It mainly about the PCE to compute and initiate the path for the BIER-TE. This draft we only include the BIER-TE, and we mainly focuses on the path calculation of BIER-TE and the controller distribute BIER-TE path to the BFIR. And the second one, it focuses on the central control scenario. It specifies a new mechanism where PCE allocates the BIER information centrally and uses PCEP to distribute them to all the nodes. It includes BFR, BFIR, and BFER. The third one is it also focuses on the central controller scenario, but it specifies a new mechanism about BIER-TE. And the last one, it specifies how to set up the multicast tree on each tree node. And it also includes the extension of PCE BIER. Next, please. Oh, sorry. We may rename the name to reflect to reflect the topic. Next, please. For this draft, we would like. We have call for adoption in the PCE working group. So, so I want to get some comments from the BIER working group. Next, please. Oh.
I'm lost. Drew, what would you like?
Yes, I'm in the queue. I'm asking, can I have the question for PC before we jump to BJP?
Yeah.
Yeah, please. If the author is fine, yeah. Mm-hmm.
Hi, I'm Dhruv. As a PC chair, hat on, co-chair hat on. It's actually not on the adoption call yet, but that's the question for the beer working group. That do we have enough consensus in the beer working group that this work is ready and let's start adopting this in PCE? So it's right now in the like chairs maintain an adoption queue.
Yeah.
We have not yet progressed it, but we want to get an opinion from the beer working group. Yes, this is prime time ready. Let's go and work on in PCE and other places as well.
Well, this stuff is not even work group adopted, right? It's still draft Chen. So
Yes, it's a PC working group document.
Okay.
It's not a
So
beer
you
document.
rolled it forward.
Yes.
Well, since I didn't read it in detail recently, I have zero opinion. You have to
So-
ask the working group.
I think then maybe I'll send an email to beer working group and let's see.
That
what
would be something. Kick
happens
us.
there.
Yes, you didn't kick us, so status is kind of undefined, right?
Okay, understood. Thank you.
Thanks, Ruth. Yeah.
Next is the draft about BGP extensions for BRTE. Next, please. This document describes the BGP extensions for advertising the BRTE specific information. It includes bit person and bit ID advertisement. And for this extensions, we reuse the beer pass attribute, which is defined in beer IDR extensions, and the content of the beer pass attribute, say below. Sorry, there is some mistake. It's a BRT TLV. We have defined 4 TLV. The first is BRT TLV. It is used to distribute the beer information. And next slide, please. And we also defined a new sub-TLV. We defined 3 new sub-TLV of beer TLV. The first is beer MPS encapsulation sub-TLV and non-MPS encapsulation TLV. It can be used to advertisement BIFT ID. Next, please. Next, we also defined a new sub-TLV of BRTLV. Sorry, the name is mistake. It's a beer position sub-TLV. It includes bit position and adjacent address. Bit position and adjacent address, encoding the bit position associated with an adjacent address, so that we can better to support the routed and connected adjacencies. Next, please. Comments welcome. Thank you.
Okay, Jeffrey on the queue.
My comment is actually about the earlier drafts, the PCE drafts. I think it's useful work, but I do suggest that to cover beer as well. And that also goes back to the earlier question in the working group status. The reason I say adding beer is actually very simple. We are basically setting up a tunnel, and that tunnel is expressed as a bit string. So whether that bit string is for the beer TE or for beer itself, it does not really matter. So you can cover both, and you don't need you only need a word change in the draft saying that this covers both beer TE and beer. So it's very easy to add, and I think it's a good thing to do. And I think it's good, a useful thing to be adopted in the PSAP, PCE group.
Thank you. I will concentrate, and I know Draft Lee had defined the PCE extension for beer. So I will talk with him, with the authors.
Yeah, we can have an email discussion on all those PCE related drafts.
But as far as I understand, this draft is standalone. It does not conflict or with any other drafts. But we can talk about it in a minute. But I think this one is fine.
Okay, thank you.
Okay, what's next on the agenda? Okay.
Okay, this presentation is for IGP extensions for BRTE, BIFT ID advertisement. I presented this on behalf of our co-authors, Ice, Benchong, and Yuehua. Next.
Yeah. Right. Yeah, I do.
So we know that we have two BRTE solutions now. One is RFC 9262, and the other one is RBS solution, which is promoted recently. So in both of the solutions, they use link BP to indicate the agency. The link BP is encapsulated in the bit string of the BRTE or RBS packet. And we know that the BIFT ID is allocated per subdomain and bit string length. So same as BIER forwarding. The BIFT ID is used for BIFT location. So we use its value to find the correct forwarding table and forward the packet. The BIFT ID can be allocated by controller. That is done by BRTE Yang. And we can also distribute it by IGP protocols. Next, please. So let's see the signaling. We can advertise the BIFT ID associated with the link BP. But if we do that, too many duplicate BIFT ID will be advertised because many link BPs use the same BIFT ID. So many bytes will be consumed according to it. So we improve the advertisement by advertise the BIFT ID as subtil V associated with BIER info subtil V, like the advertisement for BIER. So the advertisement for BIER and BRTE will be aligned. And the advertisement of ISIS, OSPF, and OSPF v3 are similar. And also, the signaling includes MPLS and non-MPLS encapsulation. Next. So any comments are welcomed. Thank you.
How many people read the draft? Oh, okay. Enough. Yeah.
Thank you.
No comments? Ongoing work? Yeah, sure.
Hi, we have read the draft and we noticed that in the BIER extension header, there is no max SI field in the header. So is there any particular reason for that?
You think we must align to the OSPF 8444?
Because if you carry max SI field, you can just use one field to contain multiple labels. But without
we can consider about it, but the allocation function is different from BIER and BRTE. For BIER, we allocated the BIFT ID according to subdomain, bit string length, and set identifier. Yes. And we allocated the BIFT ID for BRTE according to subdomain ID and bit string length only. So there are maybe too many.
Okay, so SI will not be taken into consider when you map the BIFT ID, right?
Maybe.
Okay.
No, so what's the resolution? All right, good. Okay. So yeah, list. Thanks for the question.
Okay. Is there any question? Okay. Next one.
Sorry? Yeah, we were through slides. Okay, so
yeah.
That's it?
Yeah. You move to the next one.
I don't know where you have it. Yeah. No, wait, you had just one draft. Oh, yeah. Okay, so Wei, please. So we have a damned interesting use case. After a lot of discussion, it kind of, the whole thing has been gelled down to a very clear use case where beer in certain scenarios seems to, statistically subperform. And that's something, that is an interesting discussion in scope of a much larger multicast, but I think beer has a, potential to also address this issue. But okay, Wei, go, please.
Okay, thank you, Chair. Here I would like to give some multicast use cases in the data center. The data center is the network is really different from the telecom network. And today we would like just to give some use case, and we have also done some gap analysis. Next page. So okay, here is some use cases for the multicast requirement in the data center network. In the large scale data center, there are very large network. You maybe have more than 5,000 servers. You need a very powerful network to connect them. And here I list 3 application scenarios for the multicast solutions. The first one is AI training, and the multicast can be used for the training model distribution and the parameter synchronization. And the second is the high performance computing, something like similar to the AI training, but the model totally different. And the third one is for the common cloud data center, and you should have the reliable data storage. So at that moment, maybe you need a multi-copy to store to several different servers. At that moment, multicast also is used. So next page. So here we would like to take the AI training as an example. AI training is a very hot topic, especially when we talk about the ChatGPT. And as I know, the data center for ChatGPT really have already applied the multi-cast in their network. And for those kind of network, here I would like to give an example, or reduce. Or reduce something like that. You have a parameter mask, and you would like to compute the parameter. You need to take several steps. The first step, the parameter master separates those parameters to several parts, and then it distributes the each parts to several different workers in the data center. Each worker may be a server or a GPU, and those GPU will computing those parameters in parallel. And when all the workers finish their computing, they will feedback the result to the parameter master, and the parameter master will have some calculation. Then it will generate a final result. And then finally, the parameter master have to distribute the final result to each workers. at this moment, multicast is needed. Currently, in the normal situation, the multicast running in the application level. In fact, in the network level, the multicast formed as several or multiple unicast. So the problem here is that for the network level, you have to duplicate several times for one track of the parameter. So the bandwidth will be a problem, and the congestion will be worse. And the second problem is that you should send the parameter paths one by one, and so that the latency will be worse also. So that is a big problem. And currently, in fact, as the server are using the smart NIC, if you have smart NIC, you can offload such as vSwitch functions. Of course, we can offload the multicast functions to the network, and it will dramatically improve the performance of the computing. So for this application scenario, some additional information is that the network for the data center is really large scale, and the multicast size is also very big, and the multicast service is also numerous. And the second one is
so wait, can I interrupt? So to quantify it, we're talking 100,000 somewhere there, right? Yeah. So it could be 100 millions, right? So about 100,000, something like that order of receivers.
Yes.
And hosts,
Yeah, and here is another characteristic is that you may have a big subdomain of the multicast, but you may have only limited number of receivers. So it's also a requirement for those kind of network. So next page, let's see some gap analysis. In order to illustrate the gap, we construct a very simple radar charter, and it have 3 different dimensions: network size, the multicast tree size, and the number of the services. So let's go through those existing multicast solutions. First of all, the PIM. If we have a very large number of services network, and the PIM need to maintain extensive multicast states inside the network. It may cause some problems such as the reliability challenge and the operational complexity. And for the SVPTE, the P2MPTE, if the multicast tree is very large, and the solution need maintain all of the leaves for every multicast tree, it will be very complicated. And for the BIER or BIER-TE, it have to carry a fat but non-constructive bit stream per packet. It will bring some problem, such as for the large network, as I just mentioned, if the subdomain is very big, but the receiver is very limited, and the efficiency will be very low. So, and for the SRP2MB policy, if you want to run that in a very large multicast tree, and you have to maintain the replication states for each tree seed at each replication node. So it's also very complicated, and it also heavily based on the SDN controller. So that is the gap. So for us, I think because the data center is a very special application scenario, and it needs reliable and the flexible multicast, and it also need to support the flexible model, the different trees such as the sparse tree and the dense tree at the same time, because the you may need to support multi tenants services. So it's really need enough flexibility. So conclusion is that any of those existing multicast technology cannot meet all the requirement of the multicast in the data center. So next page. We also give some our consideration. So here is some takeaways and objectives. So from a technical point of view, of course, we need a high scalability. As we just mentioned, it should support the both sparse and dense trees at the same time. It need enough flexibility. And second, it should support high reliability, because you know any packet loss in the data center network is a disaster. So the reliability is a really important thing. And as we just mentioned, the multicast, in fact, triggered by the root node. And it's different from a previous solution, such as PIM, such as BIER. The model is that if we have a IPTV user, they will trigger some new members join. But for the data center, and maybe the master need to trigger the tree construction. So sorry for taking so long time. So it's totally different. And here we think another objective is that we want the open ecosystem, such as Ethernet and IP industry can support those kind of solution, because now, as we know, such as InfiniBand, they have already had their own solutions. And we also would like to have the solution soon, because it's also an opportunity for multicast. You know, for the data center, you don't care the existing network, right? When you build a new data center, if you have a new technology, we can use that. So it's also a good opportunity for multicast technology. So
Okay.
that's all. Thank you.
Thank you for the presentation. I want to summarize the stuff, condense it, how it relates to the beer working group. Okay. So the gap analysis, so I don't see the size. We had some discussions, but given we have 65K receivers, right, and we have subdomains to boot, and then we have multi-topology whatsoever, I mean, I don't think that the size of the receiver total set is a problem. But it is clear that if you have a very large receiver set, right, and you always send to a couple of different receivers and it changes all the time, no, worst case per packet, statistically, we start to deteriorate to ingress wrap, right? And the call to action would be to close the gap. If we're interested, to extend the charter to work on something like that, people have interest, would be to address the problem of efficiency when we have few receivers on a very large addressable set, right? And, RBS being a candidate, maybe if the work group comes to, some kind of conclusion, that's the stuff or not, we go and shake it out on the list, or otherwise, alternate proposals welcome, and we can, push on that stuff and see whether it's addressable. Okay, that's kind of the gist of the thing, and we can address that. That would make beer possibly, much more applicable to this use case. Is it fair assessment?
Yeah. Okay.
Thank you.
Mhm. Okay.
So, any questions, comments?
Okay, this
name and affiliation, please.
Yeah, Zhen Bin from Huawei. Yeah. Okay, and it's good to see that we have this opinions is the convergence. That's the new requirement on the multicast, and also that's the gap analysis of the existing multicast solution. Maybe cannot satisfy this requirement. I think that this is great. That we hope that we focus on the power statement and to refine this the use cases and also this gap analysis, so that we can move this work forward. Okay.
Thank you.
Okay, not clear whether it's a question or an ask. Yeah. Okay. Name affiliation, please.
Yes, TNG, CMCC, China Mobile here. The things like, I'm sorry about that. The things like I just try to add some more data to support the work here. It's just if you consider some extensibility, and if you look at the current technologies, PIM, BIER, or RBS, that's mentioned a couple of sessions back, and then look at the AI training DCs, look at the ChatGPT. Within 4 months, the parameter increased from 1.5 billion to 175 billion, about 100 times the increase. So the things like this is something related also to extensibility. Say, well, even if you try to change the charter, I'm not sure you're going to change again in a year, or this is something more related to the DC specific the work, reliability, scalability, dynamics, and also extensibility. Thank you.
Yeah, thank you. In fact, from my point of view, it's really only such as how to duplicate or how to multipass. We need a site of a solution because the network is very embedded with the data processing. So yeah.
Okay, but I mean, it would be a productive path if you ask us why you're here and what you want to get done. Okay. If your conclusion is nothing to be done here, then please, we have tight agendas. Don't waste our time. Okay, Mana.
Yeah, Mankamna, Cisco Systems. So I think if I see in this overall discussion, we used ChatGPT a couple of times. First time when I heard this use case, ChatGPT was not even born. So I would go back, that original use case really is before even ChatGPT. 3 use cases which you have spoken, 2 out of them I really don't understand how you will have 100,000 receivers. So if you are saying that there is some data which needs to go and get stored at multiple places, will we really store at 100,000 data centers? Which I really doubt.
No, the point is more that out of these 100,000, each time they have a workload, they just pick 10. But the 10 are always different, and that's the problem, right? They have basically very short-lived flow to always changing small set of receivers. So I think there is no dynamic protocol can converge at this speed, right? It's simply you can't distribute the state fast enough and the joins and whatever. So you end up on an inclusive PIMC, right? But now they also want the selective PIMC. Now guess what? The only technology that is right there that can do that, plus bidirectional, is beer, but maybe there's some magic to be had by, enough pixie dust or something. Okay.
Yeah.
Andrew?
Yeah, so I wanted to comment a little bit on this, wearing my AD hat, having been involved in several of the discussions. The way that I see this is that there is clearly a requirement here.
Yeah.
There is also, as stated by yourself, a requirement that requires something to happen fairly fast. Now, we're in the IETF. Things take a while here, just a little while, I would like to see from my side, but again, completely up to the working group, that we explore whether or not we can make this work within the confines of this working group, because number one, it's going to speed up the development, right? It's going to speed up getting you guys to where you want to go. Number two, it prevents a further duplication of work where there is already, a lot going on within the IETF. And there's always a place for new work within the IETF. But the work, you've got to also balance resource, right? And if we have something here that could work, from my perspective, and again, I'm not going to dictate to the working group, I think that exploring this within this forum would be a worthwhile thing to do. And I'm quite prepared as the AD, if we need to make modifications to the charter to enable that exploration, I'm quite prepared to work with it. But what I would like to see is some way forward, because we've kind of had this back and forth now for quite a while. And I'm quite happy to see that there's a good use case being presented here. What I'm hearing from Tony, and I'm quite happy to hear from the rest of the working group, is there may be a way to make this work. But I'd like to give the chance, if they are saying that, and see where we go from there. That's my viewpoint.
Yes, thank you, Andrew. So I would like to provide some my consideration. Firstly, I think data center network is a really different application scenario, and the requirements, the experts for that maybe is totally different. So
if I may, let me just comment on that as well.
Yeah.
And I think this came up in another meeting that we had recently.
Yeah.
That I think that there is a multicast portion to this. There is also a data center portion to this.
Yeah.
The data center portion and data center networking in general is something that I am almost certainly going to be tabling with the IESG to see what the interest, what the process, whether or not there is enough there to potentially do something there, separate area, whatever. We haven't gotten there yet, but it's something that, as I said in that meeting, I would look at, but I don't think that that is a blocker, because remember, that's going to take time.
Yeah,
That is not going to happen fast. I don't think that that is necessarily a blocker to exploring whether or not the multicast requirements can be achieved within the confines of what already exists, which is in everybody's advantage to do.
Yeah. And the second point is that, if we start the work based on some existing or legacy work, maybe it's more harder to develop a new solution as quick as we want.
So when this group was one of the fastest moving charter in IETF, it took 8 years to get multi-vendor silicon deployed. Now, if you say I care a squat for consensus and I build my own proprietary solution somewhere and I don't show it, I show you the information, look how great the thing was, all more power to you, you will move faster. But when you go into the IETF processes and you build consensus, those are the realities to get the stuff out there. So, pick your choice, you can have both. Just sheer grown-up reality talk, right? What are we, 8 years? Now we have about 3 or 4 silicon implementation deployment. And it was a really, really fast group.
Yeah.
Okay.
Yeah.
Human?
Please.
Yeah, you kind of stole the thunder from me there. Yeah, a couple of points. You mentioned that when it comes to multicast estates, they're like trees. You do not want to have multicast estates in the data center because you have one too many applications that are doing multicasting. Okay, it would be nice to put example of the thousands of applications So currently any tree that has a multicast state within the network can go up to 10,000, 20,000, 60,000, whatever, right? That's the number of estates that we can have even in MPLS world. So, what goes beyond that, it would be nice to have something in there. The second thing is that what about cross data centers? Like, is there a need to have this multicast to go beyond the current data center, go in the inter data center link, which is usually over like MACsec or whatever, protected, and go to the next data center because there is some computes over there that they need to do the same type of computing as the first data center. So that's the next thing you need to think about.
Yep.
And last but not least, I completely agree with Tony. I mean, if you're looking for something quick, the technology right now is MPLS, IP, which you said, point-to-multipoint, RSVPT, SR policy to remove the protocol. But this is going to create a states, PIM. If you do not want a states, then it's BIER type of technology, which we are coming up with the silicon. But if you're going beyond this, there's nothing out there from, like, even BIER is great, but the problem that we're having right now is there's not enough silicon out there to deploy it all over the network. So all this stuff given together,
Yeah, that is also my concern. So if we want to base on such as a BIER to do that, in fact, BIER's industry, all the people here know. And in fact, my team about 5 years ago hoped to deploy BIER in our network, but failed. Why? Because we have a so large number of existing network. So if you want to deploy those solution in the so large network, you will take a very high cost. But why we here point to the objective, the data center is a new model. If you build this data center, you don't care other data center, existing data centers technology. You can deploy the new solution.
Yeah.
So
I'm not trying to solve that problem.
Yeah.
New technology, great, but the underneath technology will remain the same, right? I mean, what I'm trying to say is that if you want to have source multicast routing, solution is BIER. If you want to have some kind of a tree that is IP MPLS, solution is tree seed or point-to-multipoint RSVPT. You can call it whatever you want to call it, new data center protocol, whatever it is that you want to call it, but that's going to be what the silicon can support. If you want to come up with a brand new silicon, I can guarantee you that you're going to be standing there for the next 10 years trying to come up with a new way of doing it.
Yeah, that's okay for the customers, because we want a new technology, but not tomorrow. We need some window to wait for it's ready. And but if we have some legacy load for some technology, if you want to base it on that, I think that is harder. Yeah.
Am I allowed to talk?
Yeah.
Okay, just Louis Chen from Juniper. Just a quick comment, right? Because you're a data center, you will be competing with optical multicast.
Yeah.
That's possible too. I just remind you.
Yeah.
All right. So in the famous words of Eric Rosen, your problem may be over-constrained. And then he used to hang up. Okay, I think we're done for the day. Thanks for the great session. See you in San Francisco next time. Okay, so notes have been taken, I hope. Mara, thank you very much.
Just Tony, one thing. I think that this discussion we've been having in here, I think let's continue it on the mailing list as well. But if we do, let it be in the context of the use cases, as it has been here.
I think the use case have been shown, right? And how BIER is suboptimal for the staff. And that's the only really hard thing I can put my teeth in. And frankly, I'm willing to go and give time on the mailing list and more in this working group for, because otherwise, we have shitload of drafts to do, right? And real
Yeah.
problems to solve to actually get the technology out there on a wide scale. Thanks.
Yeah, thank you very much.
Yeah, thank you. Yes, yes, I have to catch Wymo. He's the guy who didn't write this stuff. Wymo. Wymo.